Have you ever wanted to build your own custom AI? One that's perfectly trained for exactly what you need? For the longest time, that was a dream that pretty much required a data center and a whole lot of money. But what if I told you that's not true anymore? Today, we're going to break down how you can build a seriously powerful, specialized AI right from your own computer. Ah, yes. If you've ever tried to fine-tune a large language model on your own gaming PC or workstation, you have almost certainly seen this soul-crushing message. You get your data ready, your code is perfect, you hit run, and then, boom, game over. Your GPU just throws in the towel. It's that wall of frustration that's kept custom AI just out of reach for so many of us. So that's the big question, right? How do you get past that memory wall and actually tap into the power of all these amazing open source models? Well, the good news is there's an answer. And it's not about buying more expensive hardware. It's about working smarter, a lot smarter. And the secret? Well, it all comes down to a set of incredible techniques called parameter-efficient fine-tuning, or PEFT for short. Instead of trying to retrain a whole massive model with billions of parameters, these methods let us make really precise surgical changes, and we get fantastic results with just a tiny fraction of the computer power. Okay, so let's break that down. On one side, you've got full fine-tuning. This is like trying to remodel an entire skyscraper. You're updating every single one of the billions of parameters in the model. It works, sure, but it takes an absolutely massive amount of memory. But on the other side, we have this much cleverer technique called LoRA. Instead of changing anything in the original model, LoRA freezes it completely. And then it just trains these tiny new adapter layers on top. We're talking about updating less than 1% of the model's total size. But wait, it gets even better. We can push this efficiency to the absolute limit with something called QLoRA. That Q stands for quantization. And this is just a brilliant idea. It takes that huge frozen base model and shrinks it down to a much lower precision. Think 4-bit before it even adds those little LoRA adapters. And the result? Just a massive, massive drop in memory usage. So how big of a drop are we talking about here? Well, this is the number that just blows my mind. With techniques like QLoRA, when you use the right tools, you can slash your memory usage by up to 90%. No, that's not a typo. 90%. This is the magic that makes it possible to take a huge model and actually train it on a single graphics card you might already have. Now, of course, these powerful techniques need the right software to make them work. The good news is the open source community has been on fire, building incredible frameworks that make this whole process faster and way more accessible than it's ever been. Let's take a look at the main players. So here's a quick look at the landscape. You've got Unsloth, which is all about raw speed and efficiency. Then there's Axolotl, the super flexible tool for power users. And finally, Torchtune, the official library from the PyTorch team, built for deep research and integration. Each one has its own sweet spot depending on what you're trying to do. Let's kick things off with Unsloth. Look, if your main goal is to squeeze every last drop of performance out of a single GPU, this is your champion. It uses custom-written, super optimized code for all the really intense parts of training, and the result is just a wild speed up. We're talking 2 to 5 times faster training, all while using the least amount of memory. It's a lifesaver. Next up, Axolotl. I like to think of this one as the Swiss Army knife of fine-tuning. Its real superpower is its incredible flexibility. Using these really simple configuration files, you can tweak pretty much every single part of the training process. It's an amazing choice if you need that deep level of customization or if you want to scale up your training across multiple GPUs. And finally, there's Torchtune. Now, this is the official library from the folks who actually make PyTorch, and its whole philosophy is about staying close to the core library. It doesn't have a lot of extra layers, which means you get a really transparent, super customizable, and scalable process. This makes it a huge favorite for researchers and engineers who want total control. Okay, the theory is cool, but let's make this real. We're going to walk through what I think is the easiest, most direct path to take a base model, teach it what you want it to know, and then get it running right on your machine so you can actually chat with it. And to make this as painless as possible, you got to pick the right combo of tools. For this walkthrough, the clear winner is using Unsloth for the fine-tuning part to get all that speed and memory savings, and then using an amazing tool called Ollama to actually run your new custom model locally. So here's our 6-step plan. We're going to load our model and data, add those efficient LoRA adapters, train it, export it to a special format called GGUF, create a simple little config file, and then run it with Ollama.
Now, it might sound like a lot of steps, but you are about to see just how simple this has all become. All right, the first 3 steps are really where Unsloth works its magic. What used to be a super complicated setup is now basically handled in just a couple of lines of Python. You tell it to load a model that's already been quantized, you tell it to add the LoRa adapters, and then you just kick off the training. Unsloth's API takes care of all the hard stuff behind the scenes. Now, step 4 used to be a massive headache. How do you actually get your newly trained model into a format that local tools can use? Well, Unsloth has a killer feature that just solves this. With a single command, it automatically merges your trained adapters back into the model and then converts it directly into that GGUF format that Ollama loves. Honestly, this one feature is a total game changer. So we've got our trained model file. Now we just need to tell Ollama how to use it. And we do that with something called a model file. Now, if you've ever used Docker, this is going to feel really familiar. It's basically a Docker file for your AI. It's just a simple text file that points to your model, sets some rules, and even defines your AI's personality. Inside that model file, you use a few key commands. From just points to your GGUF file. Parameter lets you tune things like how creative the model should be. System, this is the fun part. This is where you write the core instructions for your AI, its personality, its purpose. And template, just make sure the chat is structured correctly so the AI can understand the conversation.
And that's it. We are at the finish line. All that's left are 2 simple commands in your terminal. First, you run Ollama create, which packages up your model file and your model file into a new custom AI. And then you just type Ollama run to start talking to the model you just built yourself. It really is that simple.
Okay, so we've covered the how. We've seen the techniques and the tools that have totally rewritten the rules for building custom AI. So let's just take a step back and think about what this all really means. And this right here is the most important takeaway. The thing stopping people from building amazing specialized AI is no longer access to a supercomputer. The real keys to the kingdom now, the things that are going to create the next wave of incredible applications, are high-quality, unique data and your creativity to build something new with it. The power to create a truly custom AI, one that's fine-tuned on your data and your ideas, is more accessible today than it has ever been in history. The tools are here, they are ready to go. The only question left is, what are you going to build?